In this video, we are going to look at how to determine the molecular mass, which is also known as the formula unit mass or the molar mass. Okay, so the question says determine the molecular mass to 2 decimal places for these given chemical formulas. Okay, so to determine the molecular mass, you need to sum up the atomic masses of all the atoms in the given chemical formula. Okay, so where do we get all these atomic masses? We get all our atomic masses from the periodic table. Okay, so let me first start with an example before we solve these questions here. Okay, so here I have my periodic table. Let's say, for example, I wanted to find the molecular mass of carbon dioxide. Okay, so for me to find the mass of this carbon dioxide, I'm going to go on the periodic table and get the atomic mass of this oxygen, okay, and also the atomic mass of this carbon here. So when I go on my oxygen here, okay, you can see that the atomic mass there is 15.9994. Okay, so the question said put your answers to 2 decimal places. So we are going to round off this 15.9994 to 2 decimal places. Okay, so when we round off these to 2 decimal places, we are going to get 16.00. So it means we'll be using this as the atomic mass for oxygen. And then when we look at this carbon here, okay, the atomic mass is 12.0107 here. Okay, so let's round off these to 2 decimal places. This should just be 12.01. Okay, so if we are finding now the molecular formula for this, the molecular mass, I mean, for this formula of carbon dioxide, we are going to say carbon, okay, has the mass of 12.01, and then oxygen has the mass of 16, but we have these two here that is multiplying the oxygen, so we are going to say 2 multiplied by what? 16, which will give us 32. So we're adding this 32 plus this 12.01. We're just going to get what? 44.01. And the units for this molecular mass, okay, we're going to be using grams per mole like that. Okay, so this is the approach that we are going to follow in solving all those questions that we saw on the other page. Okay, so I'm not going to be coming back to this periodic table. I'm just going to be telling you the mass. Okay, but when you're solving, make sure you confirm the masses of these atoms that we are going to be using. All right, so let's go to the previous page and then try to solve these questions. So the first one is Ca3, and then in the brackets we have PO4 and then 2. Okay, so let's write down the atomic masses for the calcium, the phosphorus, and the oxygen. Okay, so for the calcium, if we round off its atomic mass to 2 decimal places, okay, we are going to get 40.08, okay, grams per mole. And then for phosphorus, if we round it off to 2 decimal places, we're going to get 30.97 grams per mole. And then for the oxygen, we saw that it was what? 16.00 grams per mole. Okay, so these are the atomic masses that we're going to be using here. Okay, so what are we going to do? Okay, we're going to say this here is equals to calcium has a 3 here, so it means we are going to multiply its atomic mass by what? 3. So 40.08 multiplied by 3, and then we say plus. Okay, so we have these 2 outside, that is multiplying whatever we have inside here. So we're going to put that 2 outside, and then we put a square bracket. We put first of all the mass of phosphorus, which is just 30.97, then plus, okay, 4 multiplied by the mass of oxygen, which is 16, okay, and then close bracket. So we just now have to multiply whatever we have here. Okay, so when we multiply 3 multiplied by 40.08, my calculator is giving me a 120.24, and then plus here we have 2 and then let's add whatever is inside here. So 30.97 plus 4 multiplied by 16, it's giving me a 94.97. Okay, so this is what I have now. So the remaining thing is just to add these two numbers here. Okay, so we have 120 plus, 120.24 plus 2 multiplied by 94.97. Okay, so I'm getting my molar mass as 310.18 grams per mole. Okay, so that there will be our molar mass for this first element there. Okay, or you can say the molecular what? Mass. Alright, let's solve the second one now. Okay, so for the second one, we have this formula. We have Fe 4, and then in square brackets, we have Fe. In curved brackets, we have Cn, and then 6, and then curved bracket, and then 3. Okay, so let's first of all get the molecular masses, okay, or the atomic masses for the elements that are involved. So I can see iron, I can see carbon, and I can see nitrogen there. Okay, so for the iron, its atomic mass, okay, for the iron, its atomic mass is 55.84 when you round it off to 2 decimal places, okay, as we have been told here. And then for the carbon, we know it's 12.01, and then for the nitrogen, we know that it will be 14.01. So that is what we have. Okay, so now let's multiply this. So for the first ion here, we have a 4 in front. So we are going to say 4 multiplied by the atomic mass of for iron is 55.84. Okay, and then we are going to say plus. So when we say plus here, we see that we have these 3 outside here, that is multiplying whatever is in this bracket. So we are going to say 3, and then inside the brackets we have the mass of iron there, which is 55.84, and then plus we have these ones that are also in the brackets being multiplied by a 6, and then in the brackets we have the mass of carbon plus the mass of nitrogen. So 12.01 plus 14.01. Okay, right, so this is what we have. So let's just punch these values into the calculator and see what we are going to get. So the first part here, we have 4 multiplied by 5.84, and then plus. Okay, so on the other part, we are going to have these 3 here, and then when you add all this on your calculator, it's going to give you multiplied by 211.96. Okay, and then let's add all this now. So all this here, when we punch it on my calculator, it's giving me 859.24 grams per mole. So this here will be our molar mass for the second chemical formula that we've been given there. Okay, so let's solve the third one now. Okay, so we're just going to follow the same approach. Okay, first of all, we identify the elements that are in that compound. Okay, so we have Ca, SO4, then dot, we have 2 H2, and then O. Okay, so we have calcium, and we said that calcium had the mass of what? 40.08. And then we have sulfur, which has the mass of 32.07. So you just get these masses from the periodic table. And then we have oxygen, which we said we are going to be using 16.00. And then I can also see hydrogen there, which is 1.01. Okay, so now let's find the molecular mass for this compound here. So we are going to say molecular mass of calcium, so 40.08, plus molecular mass of sulfur, 32.07, plus 4 multiplied by the molecular mass of oxygen, So oxygen 16, and then we are going to say plus. Okay, here we have 2 multiplied by the molar mass of water. Okay, so we have 2, and then inside we are going to say 2 multiplied by 1.01, and then plus 16, like that. Okay, so this is what we are going to have. Okay, this is what we are going to have. Okay, so meaning that we can do our addition there. Okay, we can do our addition. So we are going to say, okay, let me just open the calculator. So we have 40.08 plus 32.07, okay, plus 4 multiplied by 16, and then plus 2, which is being multiplied by this 2 multiplied by 1.02, we are going to get 2.02, and then we add 16 to this number, we are going to get 18.02. Okay, so I'm going to multiply this last 2 here with 18.02, that will be here. So I'm going to say 18.02, like that. Okay, so from all my addition, I'm getting 172.19 grams per mole as our molecular mass for this gypsum here. Alright, so we are done with that question. We are going to go to the next one. Okay, so similar approach. Alright, so now we are dealing with this guy here. Okay, we are dealing with that guy. So this guy here, let's write it down. So PB and then OH multiplied by 2, and then multiplied by 2 PB and then CO3. Okay, so this here is called white lead. Okay, so we have lead, we have oxygen, we have hydrogen, and we have carbon. Okay, so let's write down their molar masses. Okay, so for lead, its molar mass will be 207.20. Okay, and then for oxygen 16.00, for hydrogen it's 1.01, for carbon is 12.01. So those are the masses that we are going to work with. Okay, so the first one there will just be the mass of lead, which is 207.20, and then I'm going to say plus 2, and then inside here I'm adding the mass of oxygen to the mass of hydrogen. Okay, so this 16.00 plus 1.01, we're going to get 17.01. Okay, so here I'm just going to, in place of this O and H, I'm going to write 17.01. Okay, and then from there, what do? I say plus, and then I have these 2 here, so I'm going to say 2, and then in the brackets I'm going to put the mass of lead, so 207.20 plus the mass of carbon, which is just 12.01, plus 3 multiplied by the mass of oxygen, so it will be 3 multiplied by 16, like that. Okay, so this is what we have. So we just have to simplify now these values on our calculator. Okay, so the first value is 207.20, and then let's multiply this. Okay, so what is it going to give us? It's going to give us 34.02, and then plus. Okay, so I'll multiply all this on my calculator and then write down the final answer. Okay, all right, so when I multiply all that, I'm getting 534.36. all right, so let's add all this. When I add all these, I'm getting what? Okay, so when I add all these, I'm getting 775.5 and then 8. So this will be grams per mole. Okay, so this here is our molecular mass, or formula unit mass, or the molar mass of white lead, which is given by this formula. Okay, so let's look at the last question now. Okay, so the last question is very simple. So we just have silicon, and then we have 0, which is oxygen, and then 2. Okay, so this here is known as quartz as its common name. Okay, so we're going to get the atomic mass for silicon. Okay, so atomic mass for silicon rounded off to 2 decimal places would just be 28.09. Okay, so you get this value from the periodic table, and then the molar mass of oxygen, of course, we know that 16.00, right? Okay, so we're just going to say 28.09 multiplied by, plus 2 multiplied by 16. Okay, so this would be 28.09 plus 32. Okay, so what do we get when we punch that value into our calculators? Okay, so 32 plus 28.09. I'm going to get 60.09 grams per mole. Okay, so this here will be our what? Our molar mass uh, for this compound here, which is known as silicon dioxide. Okay, so that's it for this video. Please subscribe to my YouTube channel for more of such videos. Okay, and also share the video with your friends. For those who would like to register for our online tuitions, okay, you can access them anywhere at any time. So you can contact me on 0763 99 34 and then 77. Okay, so you can dial this number to contact me to register, and you get to enjoy our lessons and learn easily.